now that we've derived the equations, we actually want to use them, go through a couple examples how to solve some problems. Okay. Now there's some steps we want to follow in each problem. If we do this, it'll always make our life easier. One, we need to know which way is positive. Okay, so we're going to always, generally to the right is positive, but sometimes it makes more sense to go the other way. Okay? So we're always going to figure out which way is positive. We're going to figure out what we know. When we go through the problem, it's going to give us some information. And until we know what we know, we can't figure out what we want to know. So we list what we know.
I call that make the variable list.
The variable list, list the known values. Write the kinematic equation that you're going to use. So once you figured out what you know and what you want to know, then you've got to figure out the relationship you're going to use to get there. And that's usually an equation. And in complicated problems, it's 2 or 3 equations. Okay? Then we're going to go ahead and use the equation, substitute in our values, solve for the unknown, show all our work, circle our answer, and make sure we have units. Okay? So our first problem says a car is able to brake with an acceleration that has a magnitude of 10 meters per second per second. Okay? So that's the first piece of information I've got. I'm going to have an acceleration 10 meters per second squared.
Now it doesn't tell us positive or negative yet, so
It
I guess
doesn't,
we get to choose
but
that, right?
Well, let's keep reading and see what it says. It says, how long does it take for the car to stop if it's initially traveling at 25 meters per second? All right, so that actually told me 2 pieces of information. Final velocity, stopped at 0 meters per second. Initial velocity, said was 25 meters per second. Now, we're supposed to figure out positives and negatives still. So now that I know the whole scenario, I'm going to draw a picture. I've got my little car, okay, and it started and it was initially moving this way at 25 meters per second. And it ends up stopping. Okay? So I'm going to say it was moving in a positive direction. So this way is positive, which would make this way negative. Okay, now which way is my acceleration?
Okay, if they're stopping, it's going to be negative, correct?
Right. Okay? Because it's got to accelerate this way against the velocity, which is in the negative direction.
So
over here, I'll
acceleration
make that
negative.
negative.
And make our initial velocity positive.
And our initial velocity is positive. Okay? Now, we're supposed to figure out how long it takes for the car to stop. So the unknown over here in this list is t. T is unknown. Okay? Now, I have 4 values, 4 variables, VF, VI, A, and T. I want to find out a relationship between them. Our very first kinematic equation.
Consulting our equation, we have VF equals VI plus AT.
Plus AT. Okay? Now, the standard form has a positive here. Don't change that. Okay? If a standard form has a positive, you leave it positive. If its standard form has a negative, you leave it negative. Okay? So VF.
VF 25. Oh, sorry,
0
0 meters per second.
VI 25
meters per second. We're supposed to be using
meters per second. Plus
A is negative 10.
negative 10 meters per second, or meters per second squared, times time, which is t measured in seconds.
Make sure you get your meters per second.
It's got 0, it has no units. Okay, so 25 meters per second, I can go ahead and subtract that over. Negative 25 meters per second equals negative 10 meters per second times t. Divide both sides by negative 10 meters per second squared, and we get 2.5 meters per second divided by meters per second cancel, and then I'm left with that per second, but it inverts, and that's seconds equals t. So it takes 2.5 seconds for this car to slow down and stop if it accelerates at negative 10 meters per second per second.
Okay.
All right.
Too bad.
No, that's pretty straightforward.
Let's look at number 2 now. Okay, a car has an acceleration of 2 meters per second squared. If the car starts from rest and accelerates for 10 seconds, how far does it travel? Okay, so let me write down what I know. Acceleration of 2 meters per second squared. Starts from rest, so my V initial is 0 meters per second. And accelerates for 10 seconds, so I know my time is 10 seconds. How far does it travel?
Change in position. Yeah.
So I'm looking for a change in position this time. So I'm going to draw my picture. Let's just say it starts there, it's at rest, and I'm going to make this positive. And that one negative. All right, so my sign on acceleration?
Positive.
Positive.
And it actually told us that, right? The car has an acceleration of 2 meters per second squared. The other problem said a magnitude of, so we had to pick our direction. This one actually says this is the acceleration.
All right. So now the kinematic equation that has a v initial delta t and delta x would be the second one. Delta x equals v initial time plus 1/2 a times squared. So let's plug in.
Don't know that. Initial velocity
is 0 meters
It's
per
nice
second.
when that goes away because
Right.
that whole term drops out.
My time is 10 seconds. I'll put that in, but we're going to see that's going to move away. 1/2 a is positive 2, and my t is. Now this is nice because this all goes away.
0 times anything is 0.
Okay,
drops
so that's
out.
going to simplify delta x.
Let's see.
1/2
1/2 times 2 is 1.
times 10 squared.
Times 10 is 10. Now let's look at our units here, right? Our meters per second squared, and then these seconds were squared. Okay, so those meters per second squared times second squared are gone. They cancel and we leave us with meters.
Right.
So 10 squared is 100, and we get 100 meters.
And that makes sense because delta x is a displacement, and we know displacement's in meters. So it's nice to use your units to double check whether you plugged everything in correctly.
Right. If your units aren't right, then you know you messed up somewhere. Okay. All right, take a look at the third problem. How far would the car in problem 2 have traveled in 10 seconds if the initial velocity of the car had been 3 meters per second? So we still have some of the same information, but this one is different. Initial velocity is 3 meters per second. Time is still 10 seconds. Acceleration is still 2 meters per second, and we're still wanting to know how far did it go. Okay. So same pictures before. Cart's here, okay, and to the right is still positive, but now it's got an initial velocity this way of 3 meters per second. Positive 3 meters per second, right? So we know it was initially moving in a positive direction, and it's accelerating this way at 2 meters per second. Okay? So we're going to use the same equation.
But
So
it's not going to simplify
change in
like your
position or
rest.
displacement equals initial velocity times time plus 1/2 acceleration times time squared. So this equals 3 meters per second times 10 seconds plus 1/2 2 meters per second squared times 10 seconds squared. Okay. Now you'll notice my seconds here are going to cancel my seconds here.
So we'll have meters, and that'll be 30
30
meters.
meters plus, and this is still
It's still 100 meters from the last
Right,
problem.
it's still 100 meters. And I can add meters to meters, so that's good. And change in position is meters, so 130 meters. Now I want you guys to notice something. All we did was this initial velocity, okay, caused us to go an extra 30 meters. It's remember that graph that we did this with, okay, we had this. Well, that's initial velocity 0. If we move it up here, we have this. And so we had to add on this extra area rectangle, but we still had the exact same triangle in there. Okay, so all we added on was that initial velocity.
Great. Let's do problem number 4 now. Problem 4 says a car traveling at 30 meters per second can be stopped by the brakes in a distance of 60 meters. What is the acceleration of the car? Okay, so my initial velocity is 30 meters per second, and it can be stopped, so that my final velocity is 0 meters per second.
Okay, that's a tricky one. A lot of times people are like, I don't know this information, but if it ever says it starts from rest or stops, you're getting a piece of information.
Exactly.
Now, delta x is 60 meters.
And I'm looking for my acceleration in this problem. So let's draw a little picture. So I'm going to just call right positive, left negative. It's going to be stopping, so what will I expect my sign of acceleration to be?
Well, which way is it going?
It's going to be going in the positive direction.
So then our acceleration had better be negative.
So I'm
since
going to
it's-
be expecting a negative acceleration if I'm
Okay.
going to say I'm moving in the positive x direction.
Okay.
Okay, when I look at my variables here, the first thing that pops out to me is I don't have a time. When I don't have a time, the only equation I can really use is equation 3.
Third equation, which
So-
says final velocity squared equals initial velocity squared plus twice the acceleration times the displacement.
All right, let's see if we can plug in now. So 0 meters
0
per second
squared is 0.
equals initial.
30 meters per second quantity squared
Make sure you get that squared, otherwise it's going to be goofed.
plus 2 times a, which we don't know, and delta x is 60 meters. All right.
Okay, so let's just
30 squared
30
is
squared is-
900, and don't forget to square your unit.
All right, so
meters squared
meters squared per second squared.
second
I know it's
squared.
kind of goofy, but we got to do it.
plus
2 times 60 is
120 meters,
meters
times a.
whatever acceleration.
Okay.
We'll put that.
So we can go ahead and subtract one
Okay.
or the other over.
So negative 900 second squared equals 120 meters times a. Notice, got to keep that acceleration is not going to end up with the correct
Right.
sign at
And
the
all
end.
that came from is this quantity, the 900, got subtracted over. So we divide both sides by 120 meters
So 900 divided by 120,
is 7.5.
and I need my negative sign. Now let's check my units. So I've got meters squared per second squared divided by meters, which is the same as saying
Invert and multiply 1
times
over
1 over
meters.
meter. So that meter and that meter go away, and I'm left with meters per second squared. Awesome, because I know
That's
this is an
acceleration.
acceleration that I solved.
So this car is accelerating at negative 7.5 meters per second each second. Pretty straightforward. The key to doing this is get your information out there, have a picture of what's happening in the problem, and then always double check your units. It's a good way to make sure you did things